Mary and welcome back to Study Journey. So I'm back with another AMC 12 Problem of the Week video, and this one is about using Vieta's formula and logic to answer a problem. So without further ado, let's get on with the video. This is AMC 12A Problem 12 from the year 2021. All the roots of the polynomial z to the 6th power minus 10z to the 5th power plus az to the 4th power plus bz to the 3rd power plus cz to the 2nd power plus dz plus 16 are positive integers, possibly repeated. What is the value of b? So the keywords here are that it is telling you the roots of the polynomial are positive integers. And we can see that the polynomial here, it starts from the 6th power and it tells you the coefficient of the second one and it tells you the constant, but in between the a, b, c, and d, they are all variables. So it is asking you what is the value of b. So since this is a polynomial and it tells you the coefficient of the second highest power and it also tells you the constant, we can apply Vieta's formula in this situation. So Vieta's formula states that the sum of the roots of a polynomial is equal to negative b over a, where the polynomial could look like, for example, ax squared plus bx plus c. So here, if you're trying to find the sum of the roots, you would go negative b, which is the coefficient of the second highest power, and then over a, which is the coefficient of the highest power. And then the product of the roots is equal to c over a, where c is the constant and a is still the same one as here. So since it tells you that the b in this situation is negative 10, and then the a will be 1 because it is just z to the 6th power, then we can simplify this. And then this would just equal negative of negative 10 over 1, and then c over a, the constant is 16 over 1, which equals 16, and this one you simplify to 10. So now we know that the sum of the roots are 10 and then the product of the roots are 16. We know since it is raised, the highest power is to the 6th power, then we know that there are going to be 6 roots that have the sum of 10 and the product of 16. So how is this going to work? Well, we can just try to think of the possible solutions and then we can see that the roots are 1, 1, 2, 2, 2, and 2. Because 2 times 2 is 4, and then 2 times 2 is 4, so 4 times 4 is 16, and times 1 it doesn't change. And then if we add these all up, it will be 10. These are the roots. We can write it in the formula z minus 1 squared, because that is, one of the roots is 1, and then there's 2 of them, so you can square it. And then z minus 2, because one of the roots are 2, and then you put it to the 4th power because there's 4 of them that are 2. Now this simplifies down to z squared minus 2z plus 1, and then this will just be z squared minus 4x plus 4 squared, because I did it as 2 to the 2nd power, because if it is raised to a certain power, you can multiply it and then it will be the same. Now we can simplify that even more. So since it is asking you what is the value of b, and b is the one where z is raised to the 3rd power, then we can just solve for whatever one is going to be raised to the 3rd power. So just calculating just the z to the 3rd power terms, we get b is equal to, so 2, if it's raised to the 2nd power, how are we going to get it to the 3rd power? Well, can it multiply by negative 32z, and then it can be negative 32z to the 3rd power. So the first one will be negative 32, the coefficient, and then you add the second possible one, so negative 2z, 24z squared. So multiply those two together, we get negative 48, and then 1 times negative 8z to the 3rd power, and then there's no more for this one, so that is going to be it. And adding these all together, we get negative 88. So we can see that b is equal to negative 88. Looking at the answer choices, we can see that the answer will be A, negative 88.